Hey, PCalc, I need to make one adjustment to the last example I did on that previous video. And it's this. The image appears needs to be at least, see, semantics are important. What exactly did we say here? At least 3 times as large. What does that change? What it changes is we're not really dealing with an equation right now. We're dealing with an inequality. So it was initially looking like this. We know that P needs to be greater than or equal to 4. But we also know that because 6 centimeters is the focal length, that if P were to exceed 6, that, well, for one thing, you'd have 6 minus 6, and that would give a sort of like an invalid kind of divide by 0 error. So 6 centimeters, you can't be 6 centimeters, and you certainly can't be more than that because 6 minus 7 would give you a negative magnification. And we're just talking in terms of whole numbers. So what you need to do is say, well, it's at least 4 centimeters, but it's no more than 6. In fact, it's not no more than 6. It can't be 6 either. So here's a simple, more elegant way of describing that solution. I'll just random spot, right? P must be less than 6. That we know for sure. This showed us that it has to be greater than or equal to 4. All right. See, you got to be careful. I got to be careful. All right. We're going to talk about number 79 now. All right, number 79, we're talking about the braking distance of a car traveling a certain velocity. So the braking distance is d. The velocity of the car is v. It's pretty straightforward about what's happening here. It says determine the velocities that result in braking distances of less than 75 feet. Okay, so less than 75 feet. The first thing I'm going to do is take this equation right here and rewrite it as d being on the other side of the equation. Here's why. I'm not going to make the same mistake twice. It says less than 75 feet. The feet is the distance. Less than 75 feet. And we should also probably keep in mind that the distance can't be 0 or less. Because braking distance, it's sort of like distance is restricted to positive values only. So this is also greater than 0. I mean, could it be equal to 0? Seems like that would be kind of, if the braking distance is 0, you weren't really traveling at the moment you were, okay. So we've got this inequality to solve. I think it'd be pretty helpful to just pay more attention to this part as we move forward. So we've got v squared, 1/20th v squared, I'm going to talk about it like that, plus 1v. And I'm actually going to subtract this 75 to the other side of the equation. And you know what? Maybe for now I'm just going to ignore those inequality symbols and just set it equal to 0. All right, hopefully I didn't do too much in that step. At this point, we can, I guess we can try to clean it up a little bit. We can multiply everybody by 20, and then we could even factor it. Well, if it is factorable. Let's just assume that it's not factorable and we have to use the quadratic formula. So if we move to this side of the board, this marker is causing a lot of problems in trying to erase things. I'm going to get a new one. You know what, though? Sorry for being so indecisive here. I just don't want to deal with this 1/20th. It just doesn't seem too appealing to me right now. So you got v squared plus 20v minus, well, we're just doubling 75, which is 150, and then add a 0. So yeah, v is equal to, if you remember your quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. So 20 squared so we got 400 plus, looks like 6,400. Oh, is that 80? Square root of 6,400. 80 times 80. I'll be darned. I think it was factorable. So, v equals, well, it can't be the negative output that comes out of that. It's got to be negative 20 plus 80, which is 60, divided by 2, 30. So what does this tell us? This tells us that when we incorporate the 75, the velocity has to be, that's kind of like its peak velocity. So the velocity can be no more than 30, but no less than 0. And this would be in terms of miles per hour. All right, that was number 79. Number 81. And we're talking electrical resistance. So you read through that. They're giving us an equation. Yeah, right there, number 81. The electrical resistance R, all right, gives us blah, 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 blah. Here's the equation, and these are constants A and initial R. That's what that sub-zero means. So, you know what? We'll keep the problem close to the work. All right, so they're asking for what temperature is the electrical resistance equal to the initial resistance. So here's what we can do. What we can do is basically just say, let R equal R sub 0. And then solve for T. Well, these two will cancel out. I'm thinking the temperature being 0 sounds a little bit sketchy, so I'm going to check that out. No, we're right. It's 0 degrees Celsius. So these things cancel when we subtract them from both sides. 0 equals r sub 0 a t. These are just constants. Constants can be divided out when you're trying to solve for a variable. All right. 0 degrees Celsius. Let's see, time-wise, okay, we're still going strong. Assuming that the resistance is 0, so resistance would be the R. If T is equal to negative 273 degrees Celsius, find A. So we're just plugging in those two values for both R and negative 273 degrees Celsius. So R equals initial R times 1 plus A times negative 273 degrees Celsius. So minus 273A. So this is what we get when we distribute everything out and we plug in the pieces we need to. Remember, capital R is 0. Capital T was negative 273. I just used the distributive property to get through it. Now I'm going to get those on opposite sides of the equation, which add this to both sides. And actually, you can divide both sides by this constant right here. It just cancels itself out. At which point you can just say A is equal to one over 273. And it doesn't really have a unit attached to it. It's just a constant value. All right, what's the last thing we're dealing with? We're talking about silver wire here. It has a resistance of 1.25 ohms. So 1.25 is my R at 0 degrees Celsius. I don't think they're telling us... All right, let's just keep that as is. At what temperature is the resistance? 2 ohms? Oh, okay, so here's what I think's going on. We set this equal to R sub 0 times, let's see here, where are we? There we go. 1 plus AT. Now they're saying that this is true if the temperature is 0 degrees Celsius. Which, what this does is it tells us that the initial R value is 1.25. So what we can do is say 1.25 goes into R sub 0. At what temperature does the resistance become 2 ohms? So at this point, that's the resistance we're assuming. All right. Subtract the 1.25 from both sides of the equation. 0.75. Divide by 1.25. And you should get 75. Oh, I'm running out of time. 75 over 125 should be 3/5. And then here's the point at which we have to talk about finding A, but I'm going to run out of time here. So I will answer that question in class if we need to, and see you tomorrow.